Hello, this is Science for Cycle 3, Lesson 1. And first I want to give you just a little bit of an overview of what science will look like this year. So for the first 12 weeks, we will be studying the human body. The first 6 weeks will be spent studying mainly our senses, as well as a couple of specific body organs like our eyes and our skin and our lungs. And then weeks 7 through 12, we will explore the different parts of the human body in terms of organs and organ systems. And then in week 12, it will all kind of culminate where we will make model human bodies out of big pieces of butcher paper, and the kids will get to put the organs that they've colored in place on those bodies and kind of review what we've learned. So I'm really excited to study this with you. And to give you an overview of what the lessons look like, on the top of each lesson there is a Bible verse, and I would really encourage you, if you have time, either at the beginning or the end, whatever you think works best for you, to try to read that verse and even discuss it a little bit with your class, depending on age level. There's a couple of just discussion points in each lesson for those Bible verses, but I think particularly when we're talking about the human body, it's a really apt time for us to discuss how science is an appreciation of God's world and the miraculous way that He made each of us and sustains each of us, and to demonstrate that science and Bible knowledge are not separate, but science is actually studying and appreciating the glory of God that He has put into all of creation. And in this first 12 weeks, as we'll see, He's put particularly into the design of the human body. So take the time, if you feel like time allows, to read that verse and discuss it with your students a little bit, because I think it is a really cool opportunity for us and a great jumping off point for parents as they get home to further that discussion as well. Then in this first week, I would encourage you to also take the time to introduce or reintroduce our scientific method, including the song, as well as just a very brief description of what we're doing in each step of the scientific method. And then we will get to our lesson for today. So this first week's lesson is called blinking. So what we'll be studying is how we are able to see one continuous image as we look around the world, even though we are frequently interrupting our vision with blinking. So to start with, have your kids look around the room, kind of blinking really frequently and observing what they see, and then taking some long, slow breaks in vision by closing their eyes for a couple of seconds at a time, and again observing what they see and how that different kind of blinking affects the way that they are interpreting and seeing the world around them. And so our question is how we can see that one continuous image despite the fact that we're blinking and interrupting our vision. So for the research portion, there's an image or a diagram of the human eye, as well as just a very high level overview of what's happening in vision, how light enters through the cornea in our eye and then focuses through our lens on our retinas in the back of our eye, and then the optic nerve actually takes that information and transmits it to our brain, where it is then interpreted. And that interpretation that's done in our brain is actually kind of the focus of our study this week, because we're looking at something called persistence of vision, which is how our brains actually are created to hold on to images for just tiny fractions of a second so that they can be knit together as we see more images into one continuous image, so that we can see movement and we can observe the world around us without interruptions, even when we're blinking. What's really cool is that this persistence of vision is actually applied in a ton of technologies in our world. So any film that we're watching is teeny tiny fractions of seconds of still images that are all shown in succession so that our brains can knit them together into one moving continuous image. So it's something that technology capitalizes on a lot and that God has built into our brains, which is actually really miraculous. So what we'll be designing today in our experiment is that each kid will get to design their own experiment to study this persistence of vision. I'm going to show you some examples of them, and then I'll talk about how to actually put them together. So what the kids will be making it's actually called a thaumatrope, and it's been around for a very long time, way before film or anything existed. But it's similar to like a flip book. So we will be showing one image on one side of this thaumatrope, and then on the other side we will be showing another image that could be superimposed on the first image and make sense. And so what happens is when we twirl this slowly, we can see two separate images, but when we twirl it quickly, we can actually see the images superimposed on each other. So right now it looks like the fish are in the fishbowl. Not sure how well that transmits over the video, but you can see it in person. So I'm going to show you a few examples of that. So a really easy one, fish in fishbowl, gives you a nice big surface to color on over here. What's important is that the two images are able to be superimposed on each other and make sense. So if the fish were over around out here or all over the place, it wouldn't make sense, but when they are actually located where they would be inside the bowl on the other image, then it makes sense to our eyes and our brains can knit them together. Some other examples, we have a poorly drawn rocket ship, and we've got flames coming out of it here, and it says blast off. So you can see that our brains interpret it as one continuous image when we start to twirl it around like that. We've got a poorly drawn bird and a bird cage. And again, when we twirl it around, it looks like the bird is in the cage. I have found that it seems to work best when your images are centered as much as possible on this piece of paper. It seems like our brains can interpret that better, because then when we're twirling in two different directions, it doesn't kind of confuse us. So as much as they can be centered, that probably helps. We've got, this is another pretty easy one, just the ocean in the background, and then on the other side a dolphin jumping over the ocean, and so we can see the dolphin over the ocean. You could also do some fish inside the ocean or something like that. Something really easy for little kids would just be to do one color, or in this case, one large shape that's colored in on one side, and then I'll bring some small stickers for the other side so that they don't have to draw. They could just put stickers around inside where that shape would be on the other side, and that way it just looks like those stickers or drawings that they do are inside, are on top of that color, if that makes sense. So those are some examples. So each kid will get 2 cardstock circles and then attach them to their wooden kebab skewer. I found that it works best if you use packing tape to attach the first cardstock circle, like this. Use packing tape over it, and then the second cardstock circle, I'll send along some double-sided tape as well. And so to put double-sided tape on the other side of that, and then try to get it as exactly as you can on top of that kebab skewer, centered on the skewer, is really helpful. So it might be good for moms to help with that, particularly with younger kids. But then the kids can try twirling around their thaumatrope. They can do it quickly and slowly and see how their brain interprets it differently as they speed up the rate at which it's spinning, because their brain should at some point start to knit those images together so they can see them superimposed on one another. If you feel comfortable and the moms in your room feel comfortable, you could have kids pass around and share their thaumatropes with each other, or just maybe you could even have one kid at a time demonstrate in front of the class, or go around the classroom showing their thaumatrope so that they can have other kids observe the results that they got of their experiment as well. Make sure you're using hand sanitizer after you're passing things around if kids are all touching the same supplies, just so that we can be as safe as possible. So that's the experiment, and then again reinforce what's happening in our brains as we're seeing those images start to show together. Our brains are actually holding on to the image because God designed them to do that. So then when we put those two images together in quick succession, our brains knit them together because our brain is holding on to each of those images. So again, reinforce how God made us in this miraculous way and knew that this was something that we needed to be able to observe the world around us in a helpful way. If you have extra time, I'm also sending along a whole bunch of optical illusions, which is kind of another way of thinking through how our brains interpret images. Sometimes our brains can be a little bit tricked when we look at images because of the way that we are conditioned to interpret them and that God designed our brains. So these are actually really fun. There's little descriptions at the bottom of each one, and they may help. I have them in sheet protectors, but especially for the ones that are supposed to look like they're kind of moving, it may help to remove them from the sheet protectors as you look at them, so that there's not a glare on them. So a lot of them, if you focus on different parts of the image, they look like they're kind of moving. Some of them, you can see two separate images if you focus on different parts of the image. So in this image, for example, if you focus on the black portion, you can see two faces staring at each other. If you focus on the white in the middle, you can see the shape of a vase. And it's hard for our brain to hold on to both of those at the same time. We have to kind of focus on one at a time, which is cool. There's some that kind of trick our brains into thinking that things are bigger or smaller depending on the context that we see them in because of the way that our brains work. So there's more description here, more that just move. So feel free, there's maybe 12 of these or something like that. So feel free to kind of pass those around or look at them. If you want to hang on to them, if you don't have time this week, we will be talking more about vision next week. So you could hold on to them and look at them some more next week because they are really super cool. And I think that is it. Thank you.